Hi, welcome to the class notes for kind of a homework discussion from the homework that we had covered on Friday. I did promise you guys that I would come in and give you a nice summary of that. So I did want to do that as our first thing, our activity for class here on Monday, March 16th. So just a real quick summary of the vertical transformations that were covered in the Desmos activity. The one that we want to look at is this idea that when you only have vertical transformations, the vertical transformations we're looking at is a scale factor in front of the function and then a addition added there at the end. So we're calling the scalar multiple in front A and the what's being added as D. Now, kind of the effect of these when you did the Desmos activity were to look at how changing A and D would affect the graph and being able to find A and D from the graph, as well as using A and D to help you sketch the graph. So the one thing that I wanted to talk about first was the pattern for the sine and the cosine graphs. Make sure you realize that the sine follows a different pattern going around the unit circle than the cosine did, because the sine was the y-coordinate on the unit circle, the cosine was the x-coordinate. So at the beginning of the period, the sine graph follows an inflection, max, inflection, min, inflection pattern. And so when we take a look at the actual quick sketch of a sine graph, that quick sketch is going to be essentially goes up and then down first for that, and that's going to be your sine curve. Your cosine curve in that one fundamental period follows a max inflection, min inflection pattern. So it starts at the max at 0 and comes down and looks something like that. And so when we're taking a look at these idea of parent graphs, we are looking at it in terms of the pattern from the beginning of the period, which is 0, to the end of the period, which is 2 pi. So up here on the graphs that I just did, this was 0, ends at 2 pi, 0, and 2 pi, following our pattern. So the 5 key points for that fundamental period that we talked about are the quadrantals. So we do want to keep those in mind because those are going to be the 5 key points where we are putting our cycle on the graph. And the period is still 2 pi, so we repeat every 2 pi k that we have. So 0 to 2 pi is going to look exactly the same as 2 pi to 4 pi, and so on. Okay. Now, the first thing that we're going to talk about with transformations is vertical flips. So when that multiplier in front, A, is negative, what that tells you is that there is a vertical flip. And what that does is it simply changes your pattern. Your sine pattern is going to become inflection, min, inflection, max, inflection. So if I do a quick sketch of that one, it starts at an inflection, but it's going to go down first and then come up. So that's kind of what we're looking for a flipped sine graph. For a flipped cosine graph, it's going to start at a min and then come up and come down. So that would be what we're looking at for a flipped cosine graph in terms of our pattern. Right? The A itself is also related to the vertical scale. So if we take the absolute value of it, because the negative is the flip, now we're just looking at the magnitude of that scalar multiple. And that magnitude is going to be the amplitude of the sinusoid. And if you remind yourself, amplitude is the distance between the center line and max or center line and min. You might want to make a note to yourself that this is always positive, even if there was a flip in the graph. Like for example here, the distance here, that is the amplitude. It's the absolute value of that. All right, and there's several different ways to find your amplitude, especially if you're looking at a graph. Your amplitude is going to be your max minus your min divided by 2. You could also do max minus midline, or you could do midline minus min. So like in this picture, I have the first one up here drawn with it going from max minus midline, but I could also think of it here as midline minus min, or we can go from here to here. That distance, the max minus the min, is 2 times the absolute value of A, which would be your amplitude. So you have to always divide by 2. All right, the next thing that we look at in terms of the graph is your vertical translations. So the number that's being added at the end is going to give you where the midline or your center line of your transformation is. So it's going to shift it up or it's going to shift it down. Up here right now, the current midline for these graphs was y equal to 0 or the x-axis. And that's true for both of these before you shift it. So the D is going to change where that midline is. For example, if D is, say, 2, and I'm graphing f of x equals sine of x plus 2, then I know that my new midline, I'll kind of dot it in, is going to be up here at 2. My amplitude is 1. And I'm still following the same pattern it had before. So it would go inflection up 1 max, inflection down 1, and then inflection ending at 2 pi. So you can very quickly get sketches of graphs by simply looking at what the vertical shift up or down is, and including whether it was flipped or whether it was stretched or shrunk for the amplitude on that. All right, and that's pretty straightforward. And then the last thing that I'll talk about in this set of notes is the idea that your range is always your min to your max. Your domain is always negative infinity to infinity for the sine and the cosine function. And if I was given the equation and I wanted to find the min or the max, you can always simply take the midline minus the amplitude or the midline plus the amplitude to get the max. So that just shows you the formulas to use for that. All right, so that kind of finishes up the summary for the first Desmos activity. Kind of the key skills that I wanted you to have out of that would be if I give you an equation with your vertical transformations, can you sketch a quick graph of it and repeat the pattern and the cycle multiple times other than just for 0 to 2 pi? And then the other way is if I give you the graph, can you tell me what the equation is? All right, send me an email if you have any more questions. Your activity for today in class is, you've obviously watched this video. I am also going to go through and summarize the Desmos activity that you completed over the weekend, which added in the next phase of transformations, which was the phase shift. Oops, no, I'm sorry. The one that you did over the weekend is adding in how does the period change in the graph. So my next video will address these transformations, the vertical stretch and shrink, the flip, vertical shift up and down, with a horizontal stretch or shrink, which will change the period of the graph. So we'll do that in a separate video. So make sure you have completed the Desmos from over the weekend, and then once you've done that, watch the next video, which will be a discussion summarizing what you saw in that.